Welcome back to Advanced Skills Learning. Today we're talking about cost optimization for LLM systems, and why teams are often shocked by their GenAI bills, even when they believe they're using the so-called cheap models. The biggest mistake teams make is assuming that model price equals system cost. In reality, the model is only one small piece of a much larger pipeline. Retrieval, prompt construction, re-ranking, retries, agent loops, and infrastructure overhead often cost more than the model itself. Many teams optimize model selection early, but leave the rest of the system unbounded. Over time, these hidden costs compound quietly until the monthly bill becomes impossible to explain. Cost optimization, therefore, is fundamentally a system design problem, not a pricing problem. Let's break down where costs actually come from. Yes, tokens matter, both input and output, but they're rarely the only factor. Retrieval systems pull documents that increase prompt size. Re-rankers add extra model calls. Agents repeat steps, and retries silently multiply everything. What makes this especially dangerous is that these costs don't appear evenly. A small percentage of difficult queries often generate a disproportionate share of total spend. Without guardrails, these edge cases dominate your cloud bill while remaining invisible during testing. One of the biggest hidden costs is prompt length. Every extra token you send increases cost linearly, and most production prompts contain redundant or low-value context. Repeating system instructions, verbose formatting, and unnecessary examples all add up. Longer prompts also increase latency, which leads to more retries and fallback logic, creating a feedback loop that increases both cost and response time. Optimizing prompts isn't just about saving tokens, it's about stabilizing system behavior under load. Retrieval makes this worse. Many RAG systems over-retrieve by default, pulling 10 or 20 chunks when only 2 or 3 are useful. Every extra chunk inflates token usage, slows inference, and increases the likelihood of irrelevant context leaking into the answer. This is why metadata filtering and aggressive top K limits are some of the cheapest optimizations you can make. Reducing retrieval scope often improves answer quality and reduces cost at the same time, a rare double win in GenAI systems. Quick check, 2 seconds. What usually costs more long-term? A. Using a bigger model. B. Over-retrieving context. C. Running at low temperature. Keep your guess. The answer is B. Over-retrieving context. Token bloat compounds across every request, every retry, and every user session. Another common mistake is treating model choice as a single decision. Not every request needs a powerful model. Simple lookups, classification tasks, routing decisions, or summarization steps can often be handled by much smaller, cheaper models. More advanced reasoning should be reserved for genuinely complex queries. This idea, tiered model routing, lets you reserve expensive models for high-value paths while keeping the majority of traffic inexpensive and fast. Caching is one of the most underused cost optimizations in LLM systems. Prompt caching avoids recomputing shared prefixes. Response caching prevents repeated answers to common questions. Embedding reuse eliminates unnecessary vector regeneration. When implemented correctly, caching reduces cost, lowers latency, and stabilizes system behavior under traffic spikes. In many systems, caching delivers larger savings than switching to a cheaper model. Agentic systems deserve special caution. Agents loop, they call tools, they retry failed steps, and if you don't enforce step limits, token budgets, or exit conditions, costs can spiral out of control very quickly. Many agent failures aren't correctness failures, they're budget failures. The system technically works, but the cost per answer becomes unsustainable, especially when agents are deployed at scale. Quick check, 2 seconds. What reduces cost the most? A. Lower temperature. B. Fewer retrieved chunks. C. Higher max tokens. Keep your guess. The answer is B. Fewer retrieved chunks. Retrieval decisions influence every downstream cost in the pipeline. At the architecture level, cost optimization means guardrails, hard token limits, step budgets for agents, early exits when confidence is high. These controls prevent worst-case behavior from dominating your spend. Without guardrails, systems optimize for completeness instead of efficiency. With guardrails, they optimize for value delivered per dollar spent. Finally, measure the right thing. Don't just track cost per request. Track cost per successful answer. Track cost relative to user value. A slightly more expensive request that actually solves the problem is cheaper than a failed response that triggers retries and follow-ups. Cost visibility should exist at the same level as latency and accuracy. The key takeaway is simple. Cost optimization isn't about chasing the cheapest model. It's about designing efficient systems. Control tokens aggressively, limit retrieval, cache everything you can, and always measure cost where users actually feel it, because if you can't explain where money is going, you can't control it. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more GenAI explainers, practical architectures, and quick quizzes to test your understanding.